Hello, Algebra 2, this is Mr. Szabo. From time to time, I will have some of our notes that I can provide to you guys, still using the guided note sheets, but I will provide them via this quick screencast. I'm going to spend a little bit of time on this one talking about how to take notes with the screencast with these videos, and so this might come over two separate videos, but I wanted to take a little bit of time to make sure I talk about those details, what are the most effective ways to do that. And the first thing that I'll talk about is you can pause me at any time you want. If you're not understanding something, if I'm going too fast, always hit pause, write stuff down, have a sheet of paper out next to you where you can write down questions you have, and then as you come into class or as you see me the next time or just via email, you can send me questions to clarify certain things that you're seeing or not understanding from the videos. That to me is the most important part about these videos, is being able to reflect on what you don't understand and what you do, but specifically what you don't, so you can then come prepared to class to ask lots of questions and or send me messages saying, this is what I'm not understanding, can you make sure you focus on this in class the next day or the next time that we have class. So with that said, in this section, it's section 2.16 in our book, we're going to cover this and talk about this over 2 days. Today's objective is to analyze transformations of functions through equations and graphs. So the two real big key vocabulary words that we're going to have are, first and foremost, a parent function. And a parent function is the simplest form in a set of functions that form a family. So we'll talk in a minute about what that family means, but y equals x is the simplest form of a linear equation or a linear function. That would, y equals x would be the parent function. The simplest form of a quadratic would be y equals x squared, and we can make changes that form the family. Other examples, just one other one real quick, y equals absolute value of x. That's the simplest form of an absolute value function. We're going to study that in day 2 of this section a little bit in more depth. And when we talk about this parent function being the part of the family, what we're talking about is all the different transformations that we can do with that parent function. And that is, we can multiply the x by 2, we can add or subtract onto the x, we can multiply it by a negative, we can multiply it and add to it. So there's all sorts of different things that we can do that changes the function and changes the graph of the function. So it'll change the output, it'll change the result, and it changes the graph. Everything that we do to change it are called transformations. Now, moving into types of transformations that we're going to see. First, let's talk about translations. A translation is a type of a transformation. It's a type of a change that we can make to the parent function. Specifically, with a translation will change the location of a graph or the location of the function in the coordinate plane, but not the size or the shape. So it won't make it bigger, it won't make it smaller, it won't change the orientation. So if it's a parabola that opens up, it won't change it to open down. All it does is it's going to shift it. And there's two different types of shifts or movements, translations that we have. And you can move it vertically. It's a vertical translation, meaning it's going to be moved either up or down. Second one is a horizontal translation. If it's a horizontal translation, we are moving it right or left. For a vertical translation, since it's changing vertically, this changes the y coordinate. And the horizontal, since it shifts it left or right, is always going to change your x coordinate. So that's if we're talking about the ordered pairs. If we're talking about the actual physical graph, this is going to shift the graph up every point. I'm going to make that specific announcement here. It's every point. You're not just moving one ordered pair. You're moving every single ordered pair, the entire graph, either up or down. And then similarly, the horizontal shift moves every point, or shifts every point, left or right. When we talk about this with function notation, it's going to look something like this. The function, since f of x is really your y is equal to f of x, that's the same thing, we are either adding or subtracting to the entire function, which is y. And what we'll do is we'll call that, we're adding or subtracting k. So we'll choose that as our variable. If we are adding to the entire function, we're shifting everything up. And if we are subtracting, we're shifting everything down. Similarly, with this being our function, shifting left and right is also going to be adding and subtracting, but it's a little bit trickier because, in fact, we are not adding to the entire function. In this case, we are either adding or subtracting directly to the x, so inside, because I'm changing my x coordinate, not my y coordinate. So we are adding or subtracting, and since we used k here, I'm going to use h here. But this one's a little bit trickier, because when we think about positive and changing x, we think moving right. But it's actually the opposite here, and we'll explain that why in a little bit. But a positive means shift left, and a negative means shift right. Make sure you pay attention to that concept there. That's something that tends to be a little bit tricky. All right, so moving on, I'm going to go through a few of these examples and just kind of talk about what we are looking at. But here we have an x to the third. We have a cubic function, so the parent function here would have been h of x equals x to the third. That would have been the parent function. This is a translation of that. Since I am subtracting 2 to the entire function x to the third, that's a shift up or down. Subtract to the entire function 2, this would be a shift of 2 units down. And that's all we want you guys to be able to address at this point. On the contrary, if you look at part B, again, h of x is equal to the parent function. I'm now adding to the x inside my parentheses before I cube it, so I'm adding directly to the x. But addition is a shift left when it's inside the parentheses, or when it's happening directly to your independent variable. So this is a shift, forgot the h, not right, but left 1 unit. Go ahead and pause and try C and D when you've got the guess down for what's happening, and I'll give you a hint. 2 things are happening in each. Unpause to check your answers. So for part C, it's shifting it 2 units right because I'm subtracting 2 to x, and 7 units up because I'm adding 7 to the entire function. If you haven't already, try part D. Hopefully you saw that the addition means 9 units left because it's happening directly to x, and the addition outside is a ½ unit up. Take a minute now, pause, and write down any questions you have. So to now analyze the graph of the parent function compared to its transformations, specifically translations, well, let's go ahead and look at the quadratic. Here's a quadratic function, the parent function, with a table of values. If we translate this table of values, or if we translate the function to the right 3 units. What we're asking you to do is take every single ordered pair and move it 3 units to the right. So I'm going to ignore the one up at the top here for this ordered pair, but for the one that's -2, 4, 1, 2, 3 units right, that has now become +1, 4, 3 units to the right here. For -1, 1, it's 1, 2, 3 units. It's now become 2, 1. My vertex has gone to 3, 0, and then I'm at 4, 1, and 5, 4. So you can see a horizontal translation, or right or left, is not changing my y values, my output values whatsoever, but it is shifting my x values. And they've gone up by 3. -2 became +1. So why is it that my function becomes f of x equals x plus 3 quantity squared? Why did I add 3? Because I don't. We subtract 3 in here. Why does that happen when my x's got bigger? Hit pause and take a second to see if you can think that one through, and we'll come back and analyze that together. So at this point I'm going to take a quick pause and try to explain one explanation as to why when we shift the graph right 3 units it becomes x minus 3 and not x plus 3. So if we consider the parent function y equals x squared, the vertex we saw from our graph and we saw from our table is at 0, 0, because if I put 0 in for my x, I get 0 for my y. Conceptually then we saw that a shift right 3 units moved my x coordinate of that same vertex to 3, but it doesn't change your y coordinate. So if we take a look at the two functions separately and use this as our target and substitute in 3 for x, because we know that I'm moving it 3 units right, 3 plus 3 quantity squared becomes 6 squared, means my y would equal 36 if I add 3 to my x. That would give me a new vertex of, or a new point at 336 for a shift to the right 3 units. So the point that started out at point 3 should now be at 36. But because it is a shift right 3 units, I subtract 3 minus 3 squared gets me 0 squared, or 0, for my y coordinate, which is exactly the target we wanted. A shift to the right represents that this vertex has now moved to this point. And it's a subtraction of 3. Okay, so over the next minute or two, I'm going to try to go through quickly numbers 2 and 3. For number 2, I want us to notice that it's a translation up. My x-coordinates are not going to change at all because I'm just shifting every point up 4 units. It's my output, my y-coordinates, that do change. The 4 becomes 8. I add 4 to it. And my new function, because all I want to do is change the value where my output is, I use the same x squared and then add 4 at the very end. That's why a translation up or down doesn't change anything else. In number 3, if our translation left and right, we can start with the table. A translation left 2 units means my -2 is now going to become a -4. My -1 becomes a -3, and so on. But the y-coordinate also changes. Since it's gone down 1 unit, I'll subtract 1 from each of these. 3, 0, -1, 0, and 3. And then so our graph should look like this, and then it's a combination of these two concepts. And we know that we're shifting down 1 unit. A vertical translation means I am subtracting or adding to the entire function, so I can down subtract 1 unit outside. But the horizontal translation is left 2 units, so that's the 2 directly to my x, but because it's left, I am adding, and we talked about the description as to why in number 1. There is one more video. We're going to try to make it a lot shorter than the video that we just did, and that's going to cover reflections and then a quick summary. So now go ahead and go back to Google Classroom and open up the second video, please.